Let's take a look at this problem. There are 12 seats in a classroom and 12 students in the class. 3 students, A, B and C, want to sit next to each other, and they must be in the same row to be sat next to each other. It's not one behind the other, they're sat next to each other. In how many ways can this be done if? And we're going to look at various scenarios here. For the first one, there is one row of 12 seats. So if there's one row of 12 seats, remember the way we're going to do that is we're going to block A, B and C together. So we're going to have a block, which is A, B, C. And then we're going to have the other 9 students in different places. So now we have 10 blocks, which means there are 10 factorial ways of arranging those 10 blocks. And then within the ABC block, there are 3 factorial ways of arranging ABC. So it's 10 factorial times 3 factorial, which comes out at 21,772,800 different ways. But now let's think about what happens if those 12 seats weren't in a single row. What if it was 4 rows of 3 seats? So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 4 rows of 3 seats. So what could happen now? Well, first of all, let's just assume that A, B, C are going to be in this row, and we'll deal with the other options later. So assuming they're in that row, there are going to be 3 factorial ways of arranging A, B, C. There are then going to be 9 factorial ways of arranging the other 9 students. So in that scenario where A, B and C are in the front row, it's 3 factorial times 9 factorial. But we have another bit here because they didn't have to be in that first row. They could have been in row 2 or row 3 or row 4. So there are 4 possible rows they could have been in, so we need to multiply by 4. Hopefully you can see that whichever row they were in, the 3 factorial times 9 factorial would have been the same. So it's 3 factorial times 9 factorial times 4, which is equal to 8,709,120. Now let's consider what happens if there are 3 rows of 4 seats. So now we've got 1, 2, 3, 4, and there are going to be 3 rows of those. Now, in a similar way, we've got 3 possible rows they could be sat in, but let's just assume to start with that they're sat in row 1. Well, if they're sat in row 1, they could be sat here, or they could be sat there. So, assuming they're in row 1, there are 2 different places they could be sat in. They could be sat on the left end or the right end. And in each of those, there are 3 factorial ways they could be organized, because that's the 3 factorial ways of organizing A, B, and C in whichever block they're sat in. After that, we're going to have the other students. Well, there are 9 of them. So then we have the other 9 factorial students, 8 of them in these 2 rows and 1 of them here. But those 9 factorial students could be anywhere within those 9 seats. So we have 9 factorial ways of arranging them. And then just like in the previous one, we didn't have to have had A, B, and C in the first row. They could have been in the second row or indeed the third row. So there are 3 possible rows they could have been in. So we need to multiply all of that by 3. And again, hopefully you can see that whichever row they were in, the 2 times 3 factorial times 9 factorial is going to be the same. That gives a total of 13,063,680. Now let's think about what happens if there were 2 rows of 6 seats. So this time 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now we need to think about where could they be placed. Well, let's again just assume to start with that they're going to be in the front row. So the options are they could be those 3 seats, or they could be those 3 seats, or they could be those 3 seats, or they could be those 3 seats. So there are 4 different places or blocks where they could be sat within the front row. And in each of those, there's 3 factorial ways of arranging A, B, and C within that block. Again, there are 9 other students, and they can go anywhere in those 3 spaces. So that's going to be times 9 factorial. And finally, there are 2 possible rows that all of this could have happened in. We looked at it in the front row, but it could equally have happened in the back row. So we need to multiply all of that by 2. So 4 times 3 factorial for where A, B, and C are sat. 9 factorial for the other 9 students, and times 2 because it's going to be the same whether they're sat in the first row or the second row. That gives us a total of 17,418,240. And this question gives you a nice look at some of the things that they might do in an exam question, where it's not just one thing, but there's a few bits going on that you have to think about. So it's not just a simple application of one of the rules we've seen previously, it's combining that with a few other bits, and often multiple options that you need to think about.